Okay, so this is Algebra 1, Semester 2, Chapter 10.2, 10.3, Simplifying Radicals and radical adding and subtracting radicals of like terms. So, radical expressions. Radical expressions can be things that look like this, or things that look like this, where you have your radical either being multiplied by some number, coefficient, or being added or subtracted by something inside the radical symbol or the radicand. And they had to have three conditions to be considered simplified. Condition number one, the radicand has no perfect square. The radicand has no perfect square. So if you have 32, the square root of 32, first thing you got to think of is, can you get a perfect square out of that? And you can sort of divide it using the factor tree. 2 times 16, right? And then the square root stays. Well, 16 is a perfect square. And you could turn that into 4. 2 is not a perfect square, so you leave it alone. And your answer would be 4 square root of 2. You factor out all the perfect squares if you can. And then you perfect square it. You get the answer for the perfect square, and then you multiply it by the remaining factor that's also a radical. Another condition of a simplified radical expression is that there is no fractions. You can't have a fraction, for example. You can't have you can't have a radical that's a fraction like this. You can separate it out separately and then turn it into that. Or, that's one avenue. Or you can divide out the fraction also and then simplify it that way. Another way is that you can't have, that's not considered simplified, is that you can't have a fraction in the denominator. Can't simplify that way. That's a no-no. So you would have to do something to it to get rid of it. Otherwise, it won't be considered simplified. Okay. One of the things about fractions is that you can break them up. The book says this product of A and B under the radical sign can be the radical product of A times the radical product of B. For example, 48 can be broken up into 3 times 16, which can be 4 square root of 3. Okay. It's called the multiplication property of square roots. So an example that the book gives is they want the simplified form of 72. I can break that up into, I believe, 8 times 9. So that's going to be the square root of 8 times the square root of 9. The square root of 9 is 3. And there's no perfect factor for the square root of 8, so it's going to be 3 square root of 8. And then for number 2, they have a scenario where, and this is the example, they have a scenario where how do I get rid of this? They have a scenario where, what did I do? That was weird. They have a scenario where we have I don't know if that's gonna bother me. Where we have an n cubed. What the heck? Huh. Now that's interesting. How do I get rid of that? Hmm. How do I undo that? How do I get rid of that? Pen. How the fuck do I get rid of it? How do I get rid of this? Oh man. That took up a lot of time. Alright. That was crazy. Okay. So I have an N. Are you kidding me right now? So I have an N cubed. I apologize for that. That was funny. 54N to the 7th power. So I have 54N to the 7th power. This is in the book. And they want me to sort of simplify it. So I can break this up, right? 54 is 9 times 6. I can try to break this n to the 7 into something that I can factor out. So recall that n to the 7 is the same thing as saying n to the 7 raised to the 1/2 power. I can also break up that n to the 7 and say that it's n to the 6 times n to the 1, right? And I can multiply those individually by the 1/2. So I can have n to the 6 over 2 times n to the 1 over 2. And then n to the 6 over 2 is n to the 3rd. And then that stays 1/2 of n. So then I can have the square root of n to the 6 times the square root, I'll rename this way here. So this would be 9 times the square root of 6 times the square root of n to the 6 times the square root of n. 3 comes out, square root of 9 is 3. The square root of n6 is n to the third. And then we have the square root of 6 times the square root of n. I can combine those guys together. Square root of n3, 6n square root, and I'm done. So the book gives us an example of that. We have negative m square root of 80 times mn. So we'll see is the factors of 80. I can pull out 16, I believe. Yeah, I can pull out a 16, so I can rename this square root of m square root of 16 times the square root of 5. I could pull that 8, so it's usually an even number. So the square root of m to the 8 times the square root of m. I can pull that out, and that's going to be negative m times m to the 4 times 4 times square root of 5 times square root of m. The 4 goes to the front, so it's negative 4. I add that, remember there's a 1 here, 1 times 4 is 5, m to the 5, and square root of 5m. Okay. They also talk about multiplying radical expressions. So when I multiply radical expressions, I have three square root of 6 times the square root of 18. Square root of 18, I can pull out turn that into a perfect square, or pull out a perfect square. So this is going to be the square root of 9 times the square root of 2. So I can rename this 3 square root of 6 times 3 times the square root of 2. And then I can multiply these two guys separately, which gives me 3 times 3, which is 9, times the square root of 6 times 2, which is 9, times the square root of 12. I can do, for the next one, that was A, this is B. We have the square root of 2a times the square root of line times 3a. I could pull out that perfect square, square root of 2a times 3 square root of a cubed. So this would be 3 times 2a times the square root of 3, all square rooted. And that would be 3 times the square root of 2a to the 4. Right? I can square root to a to the 4, right? I can divide it by 2. It's an even number, so I can say 3a squared times the square root of 2. So remember that a to the 4 square root is the same thing as saying a to the 4 to the 1/2. So I can divide it by 2 and turn that to a squared. So that's where the a squared came from. Part C, I have 7 times the square root of 5x times 3 times the square root of 20x to the 5th. Okay, so the same thing here. I can pull out that 20. I can pull out a 4. So that's going to be 7 5x times 3. I could pull out the 4. Just going to do these separately. Actually, I don't need to at this one. Let's do that. Alright, so then that's going to be 7 5x, 3 times 4. This turns into a 2. We know that's a 2, so that's going to be 6 5x to the 5th rooted. 6 times 7 is 42. And in here we have 5 times 5, and then x times x to the 5th, right? Which is all square rooted. Then that's going to be 42. This is going to be 25. It's going to be x to the 6. Well, the square root of 25 is 5. X to the 6 is going to be divided by 2, right? So it's going to be x to the 3rd. So then 45 times 5 is 225. X to the 3rd. Okay. And this is all just variations of the product rule. Alright. Dividing radical expressions. So you can do a couple of things with radical expressions, right? You can do like 8/4 radical. You can divide it first. So this is 4 divided by 8, which is 2, right? You can do that. Or you can do it separately. So square root of 8 over the square root of 4, which is the square root of 8 over, okay, which is the square root of 4 times the square root of 2 over the square root of 4, which also gets you to the square root of 2. So you can, you have two ways you can do it. You can divide the fraction first to get to your answer, or you can do the radicals in the numerator and the denominator separately, and it'll also get to your answer. So those are two ways of doing the same thing. So the bottom one is this particular property is talking about doing the radical sign in the numerator and denominator before you solve. So for A, we have 144 over 9 rooted. So that's root 144 over root 9, which is 12 over 3. And that's going to be 4. For B, we have 36a over 4a cubed So what's neat about this is I can sort of do two things at once. I can do, I'll leave the 36 and the 4. Remember there's a 1 here, so 1 minus 2 is a to the negative 2. So we have a to the negative 2 down here, right? And that's going to flip up to the top. So then it's going to be a to the second power up here. And then I can square root that individually. And that gives me the square root of 36 is 6. Square root of a squared is a. Square root of 4 is 2. So I get 3a for b. This guy, I have 25 y cubed over z squared rooted. Here I'll root the individual 25 y3 z squared square root. So it's going to be 5 square root of y3 times z, because square root of z squared is z. I can pull out for that y cubed 3, I can pull out a perfect square because it's not considered simplified. So I can say 5 y squared times y to the 1, and then say that that's over z. And say 5 y times the square root of y over z. And honestly, I would be okay with this as well. Either one of those two I take. Okay. So rationalizing the denominator, since you can't have a radical sign in the denominator, you have to multiply top and bottom by the denominator. So here, multiply top and bottom square root of 3 times the square root of 3, and that gives me square root of 2 times the square root of 3 over the 3 squared square root of 3, which gives me square root of 6 over 3. 6 doesn't have any perfect squares, so I'm done. And I took the radical sign out of the denominator, which is the whole point. For b, same thing. Square root of 5 over the square root of 18m top and bottom by 18m. Day goes into 18m on the bottom. 5 times 18 is 90. 90, I can factor out a believe I can factor out a 9. So this is going to be square root of 9 times the square root of 10 m over 18 m, which turns into 3 times 10m over 18m, top and bottom by 3, so I got square root of 10m over 6m. Okay. Next one, I have 7s over 3. That's going to be 7s over 3s, since I can't simplify the fraction. Top and bottom by square root of 3, which gives me 21s over 3. And I cannot simplify that any further. 7 times 3. Yep, that's it. I'm done. Okay, so that's section 10.2, 10.3. Just like combining like terms and unlike terms, you can have like and unlike radicals. So the book gives us an example of 6 root 11 plus 9 root 11. Since they have the same square root, I can add these guys together, and I can add the 6 to 9, and that gives me 15 square root 11, because 6 and 9 is 15, so 16 root 11 plus 9 root 11 gives me 15 root 11. I can also subtract these guys. There's a 1 in front of here, right? So 1 minus 5 is negative 4. So negative 4 root 3 minus 5 root 3 is negative 4 root 3. I'm just subtracting it out. So here they give me, for got it A, 7 root 2 minus 8 root 2. Again, 7 minus 8 is negative 1. So negative 1, 7 root 2 minus 8 root 2 is negative 1 root 2, which just gives me negative root 2. Got it B. I have 5 root 5 plus 2 root 5. 5 and 2 is 7. So 5 root 5 plus 2 root 5 is 7 root 5. So when they're the same radical, they're like radicals, you can add them up just like terms, combining like terms. You can also simplify these things in order to get the particular radicals to combine. So here we have, for A, 4 root 7 plus 2 root 8, 28. Well, 28, I can combine that into 2 times the square root of 4 times the square root of 7, because 7 times 4 is 28. So this can be renamed 4 root 7 plus 2 times the square root of 4 times the square root of 7. 4 at 7, that turns into 2, so it'll be 4 square root of 7 plus 2 times 2 square root of 7 because the square root of 4 is 2. That gives me 4 square root of 7 plus 4 square root of 7. 4 and 4 is 8. So 4 root 7 plus 4 root 7 is 8 root 7. The answer is 8 times the square root of 7. For B, I have 5 square root of 32. I have minus 4 the square root of 18. So with this one, I can pull out perfect squares out of here. I can do 2 times 16. I can do 2 times 9. So when I rename this, I can read out this as 5 the square root of 16 times the square root of 2 minus 4 the square root of 9 times the square root of 2. The square root of 16 is 4, so it'll be 5 times 4 times the square root of 2. And square root of 9 is 3, so it'll be 4 times 3 times the square root of 2, which gives me 5 times 4 is 20, square root of 2. 4 times 3 is 12, square root of 2. 20 minus 12 is 8, so 20 root 2 minus 12 root 2 is 8 root 2. And I'm done. We can also multiply expressions, and we can multiply expressions using FOIL. We can multiply expressions using radical expressions using the distributive property, as well as adding and combining like radicals. So for number 3a, they give me the square root of 2 times the square root of 6 plus 5. So I'm going to use the distributive property. That's going to be the square root of 2 times 6 plus 5 square root of 2. That gives me square root of 12 plus 5 square root of 2. So then let's see if I can find any perfect squares out of the 12. I do. I have 4 times 3. So that's going to be square root of 4 times the square root of 3 plus 5 times the square root of 2. The square root of 4 is 2, so it'll be 2 times the square root of 3 plus 5 times the square root of 2. Those are not like terms or like radicals, so I can't combine them, I can't add them, so then I'm done. For got it B, we have 11 root minus 2, and it's being squared, right? So that's the same thing as saying square root 11 minus 2 times the square root of 11 minus 2. So we're using FOIL, right? First, outer, inner, last. So that's going to be square root of 11 times the square root of 11, which is square root of 11 times 11. Square root of 11 times negative 2. So minus 2 root 11. And then negative 2 times 11 minus 2 square root of 11. And then negative 2 times negative 2 plus 4. So then that gives me 121 square root minus 4 root 11 plus 4. And then that gives me 11 minus 4 root 11 plus 4. I can combine like terms. So 15 minus 4 root 11. Okay. And then for C, I'm going to use FOIL again to multiply these two radicals. So I have 6 square root minus 2 root 3 times 4 root 3 plus 3 root 6. So when I multiply this again, I'm using FOIL. So it's going to be 4 times the square root of 6 times 3, right? The first two, plus negative 2 times negative 4. So it's going to be negative 8, 2 and 4, and then 3 times 3. Then I got negative 2, whoopsie, that's my second term. So this is going to be plus 6 times this guy. So 3 square root of 6 times 6, then negative 8 times 3 times 3, and then minus negative 6 times 3 times 6. And you don't have to write this out. You can write 18, 9, 36, and 18 over here. Just doing this to sort of add that extra step so you can see where these numbers come from. So next going to be 4 square root of 18 plus 3 square root of 36 minus 8 square root of 9 minus 6 square root of 18. Going to do two things. I'm going to combine like terms, and I'm going to rearrange this a little bit. So it's going to be 4 square root of 18 minus 6 square root of 18. Just put these guys next to each other because they're similar. Square root of 36 is 6, so it's going to be 3 times 6. Square root of 9 is 3, so it'll be 8 times 3. So I'll leave that there. Okay. Here I can pull out a 2 and a 9. So before I do that though, I'm going to combine them. 4 minus 2 is negative, or 6 is negative 2. So it's negative 2 root 18 plus 3 times 6 is 18 plus, or minus 3 times 8 is 24. So that gives me negative 2. And I can pull this out, right? That's a 2 and a 9. So square root of 9 times the square root of 2 minus, this would be what, a 6? Minus 6. Then I can pull out that 3. So negative 2 times 3 times the square root of 2 minus 6. 3 times 2 is negative 6, so I have negative 6 square root of 2 minus 6, and I'm done. Yeah, I added some extra steps there, but if you can see it mentally, like the root 18 is 2 and 9, or you can multiply these out already. You don't have to, or you don't have to do this expanded part here. I just did that to show you where those radicals were coming from. Okay, conjugates. So conjugates are opposites of sums and differences. So we did x plus, well, these dealing with radical stuff. So the book has square root of 7 plus root 3. Its conjugate would be root 7 minus root 3. So the same radicals in the beginning and the end, just that the sign changes. One is going to be a plus and one is always going to be a minus, always. And the reason why they're conjugates is because when I multiply these guys, and I have to multiply them, you get 7 squared 7, right? minus 3 squared 3. So when you multiply conjugates, it's always going to be these two numbers and the radical sign goes away. So 7 minus 3, which equals 4. When you multiply conjugates, the radicals go away and you're just left with those two numbers underneath the radical sign, and you just either add or subtract. Most likely you will subtract them because conjugates are negatives. And that goes, that comes from the a plus b times a minus b. And we can, which is a squared minus b squared, right? We already did that earlier in the chapter. All right. So when we have a radical expression in the denominator like this, we can't have radicals, so we can multiply it by its conjugate, which is 10 minus square root 5 square root 10 minus square root 5. So we automatically know what the denominator is going to be. The numerator is going to be, we're going to use the distributive property in a little bit. We know that the denominator is already, this is a minus sign. Not there. 10 minus 5. Right, the radicals go away, you're just left with the numbers. So using the distributive property, it's going to be negative 3 times root 10 plus 3 root 5 over 5. Can I simplify this any further? I think I cannot. So I'm done. Okay. Last one is a word problem. We're not going to do that. It's more of the same. Okay, so those are our two sections. Hope you have a great rest of your day.